Hello everyone, welcome to Reliability Insider channel. In this video, I will explain how to interpret beta in the Crow-AMSAA model. If you have ever seen Crow-AMSAA beta and wonder what it really means, this video is for you. The Crow-AMSAA model describes how failures accumulate over time. Mathematically, the cumulative failure count n follows the equation here, where t is the cumulative time, and beta and lambda are parameters giving a set of n and t. On the right side, you can see three Crow-AMSAA curves with different beta values. All of them start from the same point, but they evolve differently as exposure increases. When beta is less than 1, when exposure time increases by 6, the failure count increases by 6. And over time, when exposure increases by 6 again, the failure count increases by less than 6, and the curve bends downward. That means failures are still accumulating, but the speed slows down over time. And when beta equals to 1, the failure count increases by 4 when the exposure increases by 6. And over time, with the same duration, the increase is still 4. The curve is a straight line that indicates failures accumulate at a constant rate. And when beta is greater than 1, the failure count increases by 2 when exposure increases by 6. And over time, when exposure increases by 6, the failure count increases by more than 2, and the curve bends upward. That means failures accumulate faster as the exposure grows. So visually, beta controls the curvature of the cumulative failure trend. What does this mean? This means beta describes how failures accumulate relative to exposure, and it is not a measure of physical aging of individual parts. Instead, it reflects system-level trend, and it tells us whether the failure accumulating process is accelerating, stable, or decelerating. But remember, beta only tells us how the curve moves, not why it moves in that way. And this is where many misunderstandings begin. They see the value of beta and immediately assume they know the cause. If beta is smaller than 1, they assume reliability is continuously improving, or we are on the right track. But in reality, it may simply be because early weak units burned out, not because of improvement are ineffective. In other words, beta smaller than 1 doesn't guarantee long-term improvement. And if beta equals to 1, someone will believe the system is risk-free and no new failure will happen. In fact, failures are still happening, just at a constant rate. In other words, stable trend doesn't mean zero failures. And if beta is larger than 1, many will assume the system is degrading. But sometimes, when usage intensity increases, or exposure conditions change, beta will also increase. In other words, beta larger than 1 doesn't automatically mean the degradation. So remember, beta tells us what the direction the trend is moving, but it does not tell us the reason behind it. After understanding what beta means and what it does not mean, the real question becomes, when should we actually use beta for decision making? Beta is useful when we are comparing trends under similar operating conditions, monitoring direction after a known intervention, or detecting something is changed or not. But beta alone is not enough to conclude improvement or degradation when population shifts, or when usage or reporting definition change, or when the root cause is not clear. So think of beta as a trend signal. Use it to ask better questions, to find out what changed, but not use it to declare the final conclusions. So that's how to interpret Crow-AMSAA beta. If you find this useful, please like and subscribe for more practical reliability insights. And if you'd like a deeper, structured explanation, I will cover that in my upcoming Udemy course. Thank you for watching, and I'll see you next time.